we are trying to prove this identity. So we have to pick one side and box it in. And that's going to be our goal. So which side would you like to box in?
The right.
Okay, usually we try to box in the simpler side. It was easier to get there. Okay, so then on the left, what could we do to begin?
Change it to sign.
Okay, secant is
One over cosine.
minus tangent times sine. Okay. So that's like a sine x over 1. So if I multiply, sine x times sine x would be sine squared x over cosine x. What would I need to do here? Okay, if I want to add or subtract fractions, what has to be true?
The bottom.
Common denominator. But I have that, so I can go ahead and put these together. What is 1 minus sine squared x? Cosine squared x over cosine x. Depending on how big you write, you may need another sheet of paper for some of these. What's cosine squared x over cosine x?
Cosine x.
Keep in mind our goal. We're trying to get 1 over secant.
Just flip it.
Yeah, isn't cosine and secant reciprocal? So isn't cosine equal to 1 over secant? What if you didn't remember that? What could you have done?
Move to a next problem.
Right. Go to the next side, work it, and try to turn it into a cosine also. Okay, remember your final answer should have 2 boxes that are the same. That shows me that you recognize you got to a stopping point there. All right, questions on that one? Okay, which one should we do? I'm going to try number 3. So this is not real pretty. If you were working this on your own, what would you do?
Box in the right side.
Box in the right side. That's fairly simple. So we have to take this ugly piece and turn it into that nice simplified sine squared x. So where do we start?
Change the sign and cosine.
Okay. So secant is 1 over cosine. This would be like a sine theta over 1. Tangent is sine theta over cosine theta. Cotangent is cosine theta over sine theta. Okay, if you want to simplify this denominator, we are going to need a common denominator. And to do that, you would need a skeleton. So we can do that. So on the top, if you multiply, you're going to get sine over cosine. The bottom, what's my common denominator going to be?
Cosine.
Cosine theta, sine theta. We have the top, the big one, and the denominator. We have lots and lots of fractions here. We're going to try to get rid of some. So, if I need this to be a cosine sine, what do I have to take that times? This one needs to be multiplied by a sine, right? So you could do the skeleton, or some of you I know just prefer to write it over here. Doesn't matter to me. Do I need to write it as skeleton or just... What is sine times sine? Okay, what's this one need to be multiplied by? Okay, so this was plus cosine times cosine. It's cosine squared theta.
That equals 1.
Oh, that's helpful.
And that equals
Okay. How do we divide fractions? Flip and multiply. The first one stays the same, times, and then you flip the bottom one. So then what happens? Cosines cancel. You're left with sine times sine.
Sine squared theta.
And that's what we wanted. So, if we box in the right-hand side, because the left is a little bit uglier, has more functions, 1 minus cosine squared, cosine squared is equal to 1 minus sine squared y. That was one of the identities. So then combine like terms, so you get 1 minus 2 sine squared y, which is what we wanted. That was fun. Alright, let's look at 4 or 8. Which one do you want to do?
4, 8.
Take a vote. Raise your hand if you want 4.
Yeah.
Raise your hand if you want 8.
What's easy?
Wait, what are our choices?
Yeah.
I have an opinion. 4.
Oh wait.
You guys are very indecisive.
Wait, is it tangent squared x sine squared x?
Yeah.
I feel like it's probably gonna be easy too, but I've already like worked that half before.
Oh, that's fun.
Right.
Make sure you are remembering, if you're writing a trig function, I want an angle with it. Okay,
I feel like we should box it.
which one would you box in?
Right.
They're both awful.
They're both pretty much the same, so which is simpler, multiplying or subtracting?
Multiplying.
Multiplying is probably a little simpler, so let's box that in. We can probably get there either way. The sides are pretty comparable. So if I change this to sines and cosines, tangent squared x would be sine squared x over cosine squared x. Minus, this is like sine squared x over 1. What do we have to get a common, or to subtract these things? What's it going to be? So this one will have to be multiplied by cosine squared x on top and bottom. So I would get sine squared x minus sine squared x cosine squared x all over cosine squared x. There's more than one term, so they won't cancel. If you want things to cancel, we can only have one term on top. How do we turn multiple terms into one term?
You pull a term.
We factor something out. So looking at my terms, what do these have in common?
Sine squared x.
So let's pull it out. Okay,
that's like an
1 minus
infinity.
cosine squared x, you could change that to sine squared x. So, if I group these things together, sine squared x over cosine squared x would make,
Tangent squared x.
and you're left with, is this coming back to you a little bit?
Nope.
Yes.
No, we've had a nice long break, that's why we're trying to do lots together.
We can do the whole thing together.
You guys don't mind?
I mean, I don't really mind. It's okay.
Okay, so far we have worked problem 1, 3, 5, and 8, right? Okay. Let's do some on the back.
Sure, why not?
We should do this.
Usually on my face, I would beat it.
How about, I don't know. I don't want to do number 9. 10, 11, 12, pick one.
10.
Problem 10?
No, we're doing
10 was the first one I heard.
Then let's do 13. Okay, because they're kind of cute number. Oh, wait.
Why don't you guys take a minute and see where you can get with this? Which side did you box in?
the right. Because it was smart.
So what did you do on the left?
I
Change it
factored
to
out.
sines and cosines.
Okay, so we're gonna have to multiply and change sines and cosines. Doesn't matter which one you do first.
Then I combined like
So,
Okay, so sine theta times sine theta over cosine theta would give me sine squared over cosine. Sine times cosine over sine would give us so the signs will drop. Are you guys okay if I just go ahead and write a cosine there?
yeah.
what?
So cosine times sine over cosine
Oh, I just.
will give us a sine.
Well, but I thought you couldn't do it with cancel out those two terms.
This would be, these are multiplied.
Oh, okay, so it's only if you add.
Mhm.
Okay.
Then you have cosine times cosine over sine. Gives me cosine squared.
Wait. What?
Okay, I get you.
These are over 1. When you multiply the tops, you multiply the bottoms.
Right. Okay.
Alright, where from here?
That makes it so much easier.
Well, we could combine these.
Okay, if I want to add these fractions together, what do we need? What's it going to be?
Cosine, theta, sine.
Okay. So, that's going to be kind of ugly, isn't it? Alright, so this first one, I want to go that route, it's going to help. We're going to get some cubes.
I like it just the way it is.
You like it just the way it is?
See,
Let's
this
do
one
this.
was 9, so I kind of
Huh?
at this point, and I looked up and you're already at this point.
If we try to add these things together,
Wouldn't they cancel out?
we're going to have to multiply this one by a sine. You're going to end up with a sine cubed. And we don't have any identities that tell us what sine cubed is, do we? No.
Yeah.
So that's probably not going to help. Let's try grouping it differently. This would be like cosine over 1, sine over 1. let's say I add these two together. What would the common denominator be? Cosine. So this one would have to be multiplied by cosine on top and bottom. Would you guys agree with that?
Yeah.
So you get sine squared plus cosine times cosine is cosine squared over cosine. Over here, what's my common denominator? Sine. So this one needs to be multiplied by sine on top and bottom. So you get sine squared plus cosine squared over sine. Sine squared plus cosine squared is 1. 1 over cosine is secant. Sine squared plus cosine squared is 1. 1 over sine